An electric current caused by the motion of electric charge. The rate of transfer of charges through a circuit is called current. Electrical conductors contain both free and bound electrons. If net charge Q passes through any cross section of conductor in time t, then the electric current established through the conductor is 0.t. The SI unit of current is ampere. The current due to flow of charge at the rate of 1 coulomb per second is called ampere. Charge carrier in metallic conductor are the electron of valence shell. Free electrons. An electrical field moves from low potential to high potential. The drift velocity of the order of 10 to the power minus 3 ms minus 1 c d. 2.0x 10 to the 8 electrons pass through a conductor in 5.0. Electronic charge is 16 multiplied 10 to the power minus 6. The current in ampere flowing through the conductor is 6.4 multiplied 10 to the power 6 A. Which of the following represent electric current? C. B. If 1 ampere current flows 2 m long conductor, the charge flow through this is 1 R will be 3600 Ohm's law. The current flowing through a conductor is directly proportional to the potential difference across its ends, provided the physical state of the conductor remains constant. This is called Ohm's law. Symbolically, Ohm's law can be written as D. Ohm's law obeyed in all of these. The graphical representation of Ohm's law is straight line. If R is the resistance of the conductor, then Ohm's law can be written as D is the right answer. V is equal to IR. The measurement of the opposition to the motion of electrons due to their continuous bumping with the atom of the is the resistance. The SI unit of resistance, ohms. The current of 1 ampere flows through a conductor where a potential difference of 1 volt is applied across its ends. Then Resistance of the conductor is B is the correct answer. The symbols of ohms is D. A sample of conductor is said to be obey Ohm's law if its resistance R remain constant. Resistance of conductor depends upon the nature, dimension and physical state of the conductor. A rod of length L and resistance R is cut into 4 equal pieces. Resistance of each pieces would be R upon 4. The resistance of a conductor of length L cross sectional area A and resistivity is given by R is equal to P L upon A. A piece of wire of length L and an area of cross section A has resistance R. Another piece of wire of the same material and the same length but twice the area of cross section connected to end with the previous wire. The effective resistance is 1 upon 3R. Volt per ampere is ohm. The reciprocal of resistance of conductor is called conductance. The unit of conductance is mho or Siemens. The resistance of meter cube of substance is called resistivity. The resistivity of the material having the resistance R, cross sectional area and A and length L is given by P is equal to RA upon L. The SI unit of resistivity is ohms is equal to M की power minus 1. Sorry. Ohms is equal to M. A copper wire having resistivity P is stretched in a such way that its diameter reduced to half of that of the original wire. The new resistivity will be the same. A wire of uniform cross section area is cut into the 3 equal segments. The resistivity P of each segment will be 1 upon will be the same as that of the whole wire. If the wire of a uniform area of cross section is cut into 2 equal parts, the resistivity of each part will be remains the same. The resistance of a substance 1 meter in length and 1 square meter in cross sectional area is called resistivity. When the temperature of a conductor is rise, its resistance always increase. The resistance of conductor increases due to the rise of temperature of a conductor because the collision cross section of the atoms increases. The temperature coefficient is resistivity of a material is given by the rational. Answer will be B. The temperature of coefficient of resistance of a material is given by the relation. Answer is A. The SI unit of temperature coefficient resistivity of material is K की power minus. If the resistance are connected end to end such that the same current passes through all of them, then they are said to be connected series. If equivalent resistance R of the resistance R1, R2, R3 is series, is R is equal to R1 plus R2 plus R3. The potential difference across each resistance in series combination is different. When the resistance are connected in series, the equivalent resistance is always greater than the greatest resistance in series A. When the resistors are connected in series, then the total current through each is the same. The resistors of ohms, 2 ohms, 3 ohms, 4 ohms, 5 ohms are connected in series. If the current through the 2 ohms resistors is 1 ampere, the current through the other resistors will be 1 ampere. A piece of wire of length L and an area of cross section A has a resistance R. Another piece of wire of the same material and the same length but twice the area of cross section is connected end to end with the previous wire. The efficient resistance is 1/3R. If net resistance of resistors increases, then the resistors are in series combination. In the figure above, the equivalent resistance is 6. Three resistance 5550 ohm are connected in series across 555 volt. 555 means the current flowing through them will be स्किप कर देते हैं, हम इसको बाद में देखते हैं. If the resistors are connected side by side with their ends joined together at common point, then they are said to connected parallel. The equivalent resistance R of the resistance R1, R2, R3 connected parallel is R 1/R1, 1/R2, 1/R3A. The potential difference across each resistance are connected in parallel sum. When the resistance are connected in parallel, equivalent resistance is always less than the smallest resistance in the combination. In a house circuit, all the electrical appliances are connected in parallel with the different current but the same potential difference. The resistance of 2 ohms, 5 ohms, 7 ohms, 9 ohms are connected in parallel. If the potential difference across the 5 ohms is 5V, the potential difference across 9 ohms resistance will be 5. Resistors 7, 3, 5 and 7 are connected in parallel if the PD across 5 resistors is 6. The PD across the other resistors is volt. In this figure above, the equivalence is 2/3. As the charge flows through the conductor, energy is dissipated in the form of heat. One kilowatt hour is equal to 3.6 multiplied by 10 kilowatt 5 joules. The power dissipated by resistance is given by P is equal to V2R. The power dissipated in resistance is given by all of these. The electrical energy dissipated as heat in a resistor is given by B. The commercial unit of electrical energy is kilowatt hour. इसको हम erase कर देंगे. Two wires of resistance R1 and R2 are connected in series in a circuit if R1 is more in R1. When a resistor carries a current I, the power dissipated by is P if the same resistor carries the free P. Unit of power joules second is called watt. If 1 ampere current flows through a resistor against potential difference of 1 volt, this is called watt. The practical unit power is kilowatt. 1 kilowatt is equal to 10 power 3 watt. Amount of energy delivered by the current in 1 hour when it supplies energy at B is the correct answer. Which one of the following bulbs has least resistance? 500 watt. If a 40 watt light bulb for 2 hours, how much heat is generated? इसको skip करते हैं, इसका हम बाद में देख लेंगे. The resistance of 60 watt bulb is 120 volt in line. is ये तो मुझे समझ नहीं आ रहा है, इसको मैं बाद में आप लोग को बता दूंगा इसका. The work per unit charge done by the source in moving a charge around a closed loop is called electric motive force. The total energy expended per coulomb of an electricity when the charge is driven round a circuit is called electromotive force. The unit of electric motive force is joule per coulomb. By electric motive force, current is produced. The terminal potential difference Vt of battery is always less than EMF of battery. Internal resistance is the resistance offered by source of EMF. Terminal potential difference Vt of a battery of internal resistance Y and EMF is called V. The EMF of a source is equal to the potential difference across the terminal of the source when its internal resistance is 0. The EMF of the 3 cells, each of 2 volts in parallel, will be 2. Total potential difference across the combination of 3 cells becomes maximum when all the 3 cells are connected in series. Thank you.